My name is James Turland. Hopefully some of you remember me from the previous webinar. I'm a cybersecurity consultant here at IT Governance. One of the good things is here that a lot of us that do the teaching and these webinars, we are also practicing consultants. So any of the questions that you have, hopefully I'll have some hands-on experience and I'll be able to use that throughout the course and to answer your questions. IT Governance, we're here to help you with anything that you may wish to. Oh, sorry, I've jumped a slide there. So today we're going to be looking at reporting incidents. So the actual reporting process becoming increasingly mandated throughout many standards now. Certainly regulatory, things like PCI DSS, the Payment Card Industry Data Security Standard. We see very strict, very rigorous reporting guidelines, breach reporting processes that has to be tested annually. So any organization that is required to have PCI DSS compliance, you'll be very familiar with these sorts of things. Also, more commonly, GDPR. There are elements in there that strongly advise that you have incident response capabilities. Also, as well, the NIS directive, which was kind of brushed under the carpet somewhat by the GDPR. With the NIS directive, it's all about the preservation of critical systems. So if you're an operator of essential service, so typically from any of the public sectors, or you're a private company and you provide things like oil and gas, water, electricity, certainly NHS for healthcare, any of those organizations, as long as you meet a specified threshold, you will be designated as an operator of essential services, and you'll be contacted by your competent authority, and you will have to comply with the NIS directive, of which Objective D within the cyber assessment framework is specifically on incident response and business continuity. We'll talk today about identifying critical assets. So one of the fundamental processes for pretty much all organizations and pretty much all of the most well-known standards, things like 27001, for example, they're predicated on an asset-based risk assessment. So when we assess risks to our assets, we have an understanding as well of the criticality of those assets and how they underpin the delivery of the essential service, in the case of NIS directive, or how they underpin the delivery of perhaps our services to the public, whatever it is that we do. What we should be included in the incident response plan, so we'll be having a look at what that actually looks like. The crucial part there is, no, it's not feasible to make an incident response plan for every single scenario out there. What we do is, based on the risks, based on our identified assets and their criticality, we look at the most common risks. So that can either be based on things that we've had previous experience, previous incidents, for example, experience within the team, things like threat intelligence reports that are out there, things like the NCSC give lots of guidance on that. We have EU CERT, US CERT, lots of other vendor-specific threat intelligence sources that we can use, Microsoft, Cisco, Symantec, all of those kind of big security vendors as well. And then the critical part of that is we document those scenarios and we test them robustly for efficacy. We'll be looking at some typical attack scenarios today, and they're certainly what I've just said. They're the things that you're going to be wanting to defend against. And we'll look about some of the services that we can offer. Without further ado, this is IT governance in a nutshell. Started off implementing what's now known as ISO 27001. On the back of that, helping other businesses to achieve compliance with 27001. Large representation in governance, risk and compliance, cyber resilience, auditing companies to 27001, cyber essentials, but also other standards that are becoming much more popular now. So helping companies achieve compliance with SOC 1, SOC 2, readiness assessments for the NIS directive, as well as more technical consultancy around penetration testing and vulnerability testing, which many of the recognized standards, things like Cyber Essentials, ISO 27001, SOC 2, require mandated penetration testing. So the stages of an incident response plan. So we have to have an overview and we have to define objectives. So much like we would have a scoping exercise for anything like 27001, we do a similar thing here. So we have an overview of the organization. We have the objectives of the incident response plan. So obviously to minimize disruption to the business, to remain productive. We outline responsibilities for updating the plan. So again, tying in with things like 27001, which is all about the information security management system, which is supported by a clear cyber governance strategy. We outline the scope of any plans, which may be specific to a given asset, a given threat. And we outline as well, importantly, any exclusions, so anything that's out of scope. As I mentioned before, it's based on the assumption that we understand our critical assets. So if we don't know those, that's an exercise that we will have to go away and do. But we want to have a business impact assessment. So if we know how critical the assets are, we can understand what the business impact is if we lose that asset. Things like, as I said, the NIS directive, it's fundamental that you understand the criticality of your assets, because a compromise of the asset, be it a cybersecurity incident or be it any form of incident, could be a natural disaster, for example, it could have an underlying effect to the delivery of the essential service. Certainly if you have a required threshold, and also perhaps even with clients, if you have service level agreements, for example, you could be in breach of contractual agreement. When we've identified the critical assets, we want to assign owners to those assets. Certainly that's something that we would do if we were doing any kind of risk assessment that's going to be compliant with 27001. We want to know the location of those assets. Obviously that's very important when undertaking any form of incident response, because we need to know, first of all, is there anybody on site at that location? Can they have physical access? Lots of incident response plans will require physical access to devices, perhaps in order to reboot things, segregate them from the network example. Perhaps as well, if it's a physical breach, somebody to go and have a look at what damage was caused. We need to understand the threats. So again, that's something that's going to improve as you iterate through the process, as you risk assess continually, using things like your threat intelligence sources, past experience, perhaps penetration testing, all those sorts of things. The vulnerabilities as well, again, are going to be identified through penetration testing, perhaps your network topology, perhaps your approach, your risk appetite, your staff training and awareness, all those sorts of things. And ultimately what we're trying to get to is understanding what our maximum tolerable period of downtime is. So how much downtime can the business suffer before there's kind of a knock-on impact to that service delivery? That could be breaching service level agreements. It could be not meeting client expectations. It could be the moment at which we start to have reputational damage, for example. And we also are going to be talking about the incident reporting process itself. So inclusion of a documented incident reporting process and incident reporting escalation paths. So as we discussed previously, we've got established teams. We have different hierarchies at the kind of gold, silver and bronze levels. We'll need to know when to escalate within the team, the actual reporting process, so documenting evidence, and also any voluntary or mandatory reporting we'll have to do, perhaps, for example, mandatory reporting of a personally identifiable information breach under the scope of the GDPR. So we have that risk assessment. We identify critical assets and the various risks that could affect those assets. Lots of different ways of doing that risk assessment. Public sector have a lot of good guidance from UK government on what process they may do. May use, certainly down to the level of NHS will have their own specific way of doing their risk assessment. The military may do something else. Things like in business, you may go for approach as OWASP recommends, the Open Web Application Security Project. They'll typically look at breaking down threat actors, vectors, those sorts of things into a scale of 1 to 10. Again, This is, in some respects, as much of an art as it is a science, certainly if it's the first time you're doing it. And as you go through the process, as you refine it, as you go through that cyclical process, you'll improve and will have a greater understanding of what that risk is. Then we combine that with the business impact assessments once we understand the risks that they face, and we can determine the priority for the protection of critical assets. Essentially, what we're trying to do here is risk assess, understand the criticality, and then put controls commensurate to that level of criticality and the risks faced to those assets. So we're going to apportion more financing, more funding, more resourcing, more time to defending the assets that are more critical to the business. Pretty straightforward. So the risk assessment, the process of identifying, analysing and evaluating risk based on a suitable risk assessment methodology. And as I said, that'll be different for what sector you're in. Not strictly a case of a right or wrong methodology, it's just more a case of which is the most appropriate and do you feel that it suitably defines your risks. If you're not suitably happy, you'll need to go back and redo the risk assessment until you think that you have all variables covered. It's fundamental for the incident response process, as we've just mentioned. You can't have an incident response process if you don't fully understand the risks, because any scenarios that you create may not be accurate, may not take into account all vulnerabilities, for example. It's the only way to ensure that the cybersecurity controls you choose are appropriate to the risk your organization faces. Identifies critical assets that could be affected by a cyber attack, such as hardware, systems, data, or processes, and then identifies the various risks that could affect those assets. We want to select appropriate controls to treat risks, and again, for example, if we're doing 27001, we may refer to 27002 for a list of controls. If we are operating in the cloud, we may wish to choose some controls from the cloud controls matrix. We may wish to implement SOC 2. Again, the process is the most important part here. The controls that you implement are down to you. Monitor, evaluate, and review the risks on a continual basis. Most definitely, because we need to be able to monitor and evaluate. So how is the system performing? Is it performing optimally? Is it performing in line with the sensitivity, the criticality of our assets? Do we feel suitably protected? And also on a continual basis, because as we know, the cyber threat landscape is constantly evolving, constantly changing. So therefore, our response plans need to be updated. We need to monitor their efficacy, evaluate it, and make changes where necessary. A business impact analysis determines the priority for the protection of those assets. So it's used to determine what would be the maximum tolerable downtime or outage that the entity, department, or service could tolerate. We have an impact rating that can be measured in the form of a qualitative or quantitative metric. So for example, it could simply be a service level agreement whereby we have to have X number of hours uptime throughout the year. So we need to make sure that we build that into our incident response plan, because we don't want a plan that says we'll get our critical servers up within a week when we've told all of our customers and clients that we're only going to have 99.9% availability, so we can have just over around about 30 hours a year downtime. The impact as well could also be qualitative. So although you're going to be hit with some quantitative measures, so for example, let's take fines from the GDPR. We know what those numbers are. We know what those breaches look like. However, in some cases, it's actually that qualitative, it's that reputational damage that could actually be the much higher impact. 4% of turnover, yeah, it's scary, but if it's such a catastrophic data breach that nobody wants to do business with us, we lose our main client, that could be far more significant than that 4%. And it helps us to understand exactly what impact an incident would have on an organization. The output of the business impact assessment provides a definitive list of critical assets, threats, vulnerabilities, and the maximum tolerable period of downtime. Again, that's something that you're going to want to liaise with different areas of the business. This isn't just an IT problem. Your incident response team should be formed of members throughout the business who are responsible for the delivery of all services, meeting contractual, legal, regulatory obligations. We want to compile a list of the most critical assets. So once we've done all of this process, we'll have a document listing the most critical assets to the business or delivery of the service. Then we'll target the assets with the biggest threats and vulnerabilities and the least tolerable period of disruption. And then we'll create scenarios, as I mentioned before, the most kind of credible, most likely scenarios, the threats that are going to be faced by those assets, either based on past experience, incidents that the organization have already witnessed, or things that we're seeing through threat intelligence, perhaps in the media, or as a result perhaps of clients that you're now doing business with who by proxy could be in a bad light and therefore may make you a more attractive target. For each of those, we're going to have planned scenarios, and it's going to be a phased approach based on what we call the cyber kill chain. So the cyber kill chain is a piece of work done by Lockheed Martin over in the US. The idea being that offense informs defense. So if we can think like an attacker, we can put countermeasures in place to hopefully thwart that attack at various stages. It's based on an idea that traditional information security is an assumption that you know which path an attacker will take through your network. However, it doesn't really work like that. In reality, attackers rarely come through the front door, or in this context, your gateway firewall. And it's kind of an old hat thinking that the perimeter defense is enough these days, because we've seen the kind of proliferation of zero-day attacks, which will go straight through that, but also things like social engineering, internal threat from employees, contractors, etc. So that old approach just isn't feasible anymore. It does not work. It's not fit for purpose. So what is it? It's a sequence of stages required for an attacker to successfully infiltrate a network and exfiltrate data from it. Each stage demonstrates a specific goal along the attacker's path. And how does it support us? Designing your monitoring and response plan around the cyber kill chain model is an effective method because it focuses on how actual attacks happen. So we'll introduce it now, and it's sufficiently high level because it's a little bit like a framework, so it needs to be adaptable. But the critical part is the process. It's the methodical approach to assessing that risk, understanding how any vulnerabilities you may have could be exploited. So if you think about the reconnaissance phase, it could be, let's say, for example, harvesting emails, social networking. Okay, that's a great way to do a spear phishing email. Lots of companies are very happy to show off their staff. HR will often make their LinkedIn profiles look very good. But for an attacker, that's a great piece of information, because if you're senior, let's say, for example, you're the sysadmin, network admin, whatever, let's say you're on there, someone with a privileged account, and we can see that. Perhaps we can see who you report to and who reports to you. We can build up some form of corporate hierarchy, such that then when we start to begin to formulate that phishing email, perhaps it's a password reset email, we're trying to spoof your credentials, or perhaps it's trying to do a purchase request, we can actually doctor an email and make it look as though we've got various approval from different people. And then if we breach any of your technical defenses, maybe your automated email scanners, for example, we're then reliant on the person at the end to detect it as a phishing email. Again, it's probably going to look pretty legitimate, so the user may act upon that. And then we're based on, as we've seen, people, process, and technology. We're down to that last step, which will be processes. And if we don't have clearly documented processes within the organization, we don't say that, well, we've got a specific system, we don't do purchase requests through emails, then there's a risk that somebody actions that, and all of a sudden we've had a successful attack based from that. Again, it could be the technical as well, so passive searches, IPs, port scans. Anyone who's familiar with things like Norse map, which if you're on your browser now, Google for Norse map and have a quick look at that. If you want to scare the board or get buy-in, it's always a nice little tool to have. If we're sending, if we're configuring servers, or we're dealing a public service perhaps, if we've misconfigured our servers and they respond to things like pings, or we can make requests and they give away maybe the version of PHP that's running on the web server, all of a sudden we're disclosing information, we're making ourselves available, and that's all part of that reconnaissance process. The next phase will be weaponization. So developing an exploit with a payload creation, malware delivery systems or decoys. Let's take, for example, WannaCry. We saw how that was weaponized using one of the NSA's zero-day attacks through the Eternal Blue, that SMB exploit. We'll then have a delivery, so it could be spear phishing, infected websites, things like farming attacks, so spoofing the website, watering hole attacks, things like compromising a popular website, such that we want everybody to go there, perhaps not too dissimilar from what happened with BA the other week. Again, things like USBs, we've seen examples of people dropping USB sticks in car parks, for example. People are always keen to see what's on these sorts of devices, naturally quite inquisitive, so plug that device in, all of a sudden you've compromised your computer and possibly the network. The exploitation as well, so that's the activation, it's the execution of code, it's the first step at which the attacker may establish a foothold onto the network. It could be a third-party exploit as well, so that's always something we need to be mindful of now. And again, as I was saying in the previous slide, that old notion of kind of the perimeter defense being the solution, it's just not the case anymore. We've seen high-profile breaches such as Target, where they were actually compromised by their refrigeration contractor. So I'm sure when they were doing their risk assessments, hopefully they did do them, that probably fell straight through the radar. But because they had access to their client portal, they were naturally a target that through reconnaissance, people exploited. At some stage, there'll be an installation, so it could be a Trojan or a backdoor, something that's going to allow the attacker to get into the network. There may be escalation of privileges, so trying to be able to gain privilege on the system or the network, do things that they shouldn't be able to do. Perhaps deploy rootkits in an effort to establish persistence, so to be able to stay on the network, possibly establishing command and control, such that once they're in the network, they can communicate internally and externally. Possibly lateral movement, so perhaps they've compromised a web server, but what they're actually wanting to get to is the payment card environment, much like in the Target attack. They compromised the vendor portal, but their target was to actually laterally move through the network until they got to the card payment environment. They're possibly going to be doing some internal reconnaissance there. So again, more evidence of why the perimeter defense, so that intrusion prevention system, yes, we need it, it's vital, but it's not the be all and end all. So having things like intrusion detection systems internally is just as important. When we talk about the Target breach again, they actually had intrusion detection systems internally, but they had a systemic process failure whereby the alerts that were generated from these systems went unheeded. So again, no point in having these systems if we don't have a process in place to absorb them. And they're obviously wanting to maintain persistence at this point, so be able to stay in the network so that they can do the actions on the target. So once they're in there, they can possibly expand that compromise, take out further systems, consolidate that persistence, and then actually do what it is they want to do, whether they want to compromise data, change the integrity, perhaps exfiltrate that data. And again, things like data exfiltration, such as in the Target attack, they managed to set up internal servers on their network without them knowing, and they stole over 11 gigabytes worth of data, which if we had internal monitoring, we would be able to see which traffic's flowing from which networks, subnets, etc., what protocols, what ports it's using, and also perhaps even be able to scan that traffic if we have proxy servers, packet inspection, all those sorts of things. And hopefully there's lots of different controls we can put in at each of these steps to try and mitigate it. So the actual response plan itself follows 7 phases. We have that first phase, which is the detection. So obviously, very important, the sooner we can detect something, the better. Most breaches are actually discovered by third parties or the public, for example. So what does that show about our own visibility on the network? The next phase is the reporting process, so actually reporting the incident that's currently going on. Typically, that will be something like a help desk or a ticketing system where a user will ring up and say, I've got this message on my screen, it's asking me to pay for Bitcoin, I can't access my files. So possibly got a ransomware attack there. During the investigation phase, more of that will become apparent. And then depending on the severity of that incident, say for example, it is a ransomware attack, perhaps we assign a critical tier 1 priority incident there. So therefore, the information security manager will be informed immediately, and then the information security manager will decide whether they escalate that up to the gold level, so the board level, and invoke a full-blown incident response. At that investigation stage is probably the point where you're going to declare whether it's a full-blown incident or not. You'll have an initial kind of triage phase, followed up by some further actions. You'll then invoke your recovery plans, which you hopefully have. It's one of those most likely scenarios that you've documented, you've tested, and you've planned. And then most critically, you have that follow-up plan, which in many organizations actually they forget to do this part because they've done the recovery, the backup and running, but actually when we go through that follow-up, we find processes that were perhaps suboptimal, things that didn't work, perhaps even things that broke policy and broke process. So we actually think that maybe a system's configured this way, set up this way, when actually it didn't follow the plan. People have done a bit of shadow IT, whatever. I mean, ultimately when we're in incident response, the most crucial part is actually getting the business operational, delivering that service. But in that follow-up stage, we need to go back and make sure that everything's secure, following the correct procedures, and updating documentation, making improvements where required. So the actual incident response plan. So think about scenarios as we've mentioned, a number of detailed step-by-step pre-prepared and tested incident scenarios covering the organization's most critical assets and the biggest threats to these assets, including all of the steps required to recover the data, system or service from a particular scenario. I've got first-hand of experience of this, whereby I wrote a lot of these policies myself based on lots of good practice, lots of evidence that was out there. However, when it actually came to enacting it, first port of call was, right, okay, ring the third party. Okay, on paper it looked good, but actually the third party, they weren't available on the Saturday. Certainly in the West, we see a lot of attacks coming on kind of a Friday evening because they know that nobody's going to be in the office until Monday morning. So as a result of that, it actually required us to change the level of service provided by our third party and even consider a different third party as a result. Also, one of the important things for these scenarios and any remediation efforts, the plans that are involved, they should be written at such a level that anybody within the incident response team can understand them and should be able to follow the steps, such that, I don't know, perhaps a portion of the incident response team are away at a conference, for example, and are stuck, and that's when the breach happens. Everybody else in the team should still be able to follow these documented processes. The following should be pre-prepared documents and generally included as separate appendices, a bit like you would have with an information security management system. These will be core documents that are regularly reviewed, updated, have ownership, accountability, and they are stored in a location that all the team are aware of. So incident response team contacts, so we want to think about current whilst we're during working hours, out of hours, mobile, landline, in case we don't have signal, all those sorts of things. Internal and external contacts, again, any service or system that has a dependency with perhaps third-party systems or with clients that you have service level agreements with, etc. You want to have an incident response actions checklist. And the SANS Institute actually have a lot of good documentation on that, so it's probably something you want to go to the SANS website for their incident response checklists. An evidence log, which will typically fall down to the role of the documenter within the incident response team, whose duty is specifically to document and provide evidence of all the changes and all the processes that are going on there, because certainly at the gold level, probably making high level decisions, very important decisions. Everybody's probably too busy to actually be documenting because they're so focused on actually getting the system and the service back up and running. But that evidence trail, that logging, certainly as well when we come to think about making a press statement about this, the robustness of our logs, the evidence that we can collect has a profound impact on how well we can actually deal with the incident. We want pre-prepared incident response communications. And as I said, this isn't just an IT issue. The incident response team has representatives from all of the business, from the board all the way down to the kind of the button pushing, actually bringing systems back up and running, senior management, everybody. We want conference number details, again, if applicable, and clear links to the business continuity plan, because as mentioned previously, certain incidents will invoke the business continuity plan by the nature of their severity. And that'll again go back to your assessment of the criticality of your assets. We want scenario tests and testing. Once the plans are in place, they need to be tested to judge effectiveness, and you'll have a feel for what that will look like when you invoke those plans. What kind of level of assurance would you like to have from them before you believe that they're effective, fit for purpose? Scenarios to potentially be updated based on those testing results. So as I said, when you do test, much like an audit, there's always going to be minor findings, possibly even major, that you'd want to go and address. You need to have some understanding of how often you're going to invoke those tests. I would suggest certainly biannual, if not annually at a minimum. You want to clearly define what the scope of those tests are so that you can very narrowly focus down onto what's important. Start off by understanding, I guess, specifically what the service is that you're wanting to protect. Defining whether the plan was readily available. Did everybody understand it? What deviations were there? Again, documenting those, because that may be evidence that the plan isn't fit for purpose. There's lots of improvements to be made. Perhaps people haven't had adequate training, etc. Speaking of training, it's crucial that training and awareness is provided to the whole organization, specifically the incident response team, and that training is probably commensurate to their duties within the team. And again, that's a decision that you are going to have to make yourselves. For instance, you may actually wish that help desk, those first responders, actually receive some additional training, because as I mentioned before, the sooner you can understand and detect what type of attack it is, hopefully you can expedite the whole incident response process, perhaps mitigate a business continuity event, and ultimately be up and running in fewer hours, days, weeks, whatever it may be. So we need to think about incident identification, the incident reporting, how we're going to classify that incident, so based on the criticality of the assets, again, other things perhaps based on even things like your network topology, how you segregate the network will have an impact on its classification. The incident scenario testing, business continuity, and then your actual technical disaster recovery process. And again, whether that's something you have the capability in-house or whether that's something you wish to outsource. And again, you'll have to have a think about, well, when do we actually pick up the phone and ask for further assistance? And much like 27001, predicated on that continual improvement process. So cybersecurity and incident response needs to be part of that bigger picture. Task needs to be assigned to at least one person in the incident response team who's responsible for continually reviewing this documentation, going through these processes, scenario testing, and continually improving. So the phases, quite simplistically, we'll go through them. Detect, so precursors and indicators, they could be things like network intrusion detection sensors, antivirus software, file names with unusual characters, anything. And again, this is going to be based on the tools and the systems that you have available and whether you're actually monitoring them, much like Target had, but weren't monitoring them. And also your user awareness, so how aware users are, certainly around things like social engineering, phishing attacks, would they know what they look like? There's sources of detection. security software, system logs, threat intelligence. Could be things like SIEM solutions. You've got all your logs plugged into those, and they are actively being parsed. The report, so all the W's, what, when, how, where the incident occurred. Current status of the incident and a description of the incident. So again, be mindful that the incident could be ongoing. So that's something we will want to document. We need to understand the affected resources, and that'll probably come from either our end users, but also monitoring of our systems. A step-by-step explanation, if applicable, certainly in the example of maybe some malware that came in through an email. What did the user click? What did it say? All those sorts of things. What does the screen look like? Are there any error messages? If possible, begin to categorize the incident at this stage. This may then invoke certain prioritization factors that you've predefined. Perhaps also as well, there could be mitigating factors at this stage. You may think that, okay, I'm successfully identified it as ransomware, which is quite easy to do because it's in your face and it usually tells you exactly what it is. Being mindful though that there could be other malware that came in with that piece of malware, but you may make a decision at this point because it's malware. The first responders have the authority to tell the user to disconnect the Ethernet cable out the back of their machine, leaving it on for digital forensics, and that could actually thwart the attack right there and then. However, that might not be a blanket approach. For example, perhaps if it's infected a server, we don't actually just want to disconnect the server because that may have kind of a cascading effect, may actually make other systems worse. We don't know what the dependencies are there. So something to be mindful of, but as much as possible, try and mitigate the threat at that stage, gather as much information as you can. The investigation phase, so now we know a little bit more about it from the report, we're analyzing that report. Typically that will be escalated, as I said, to the information security manager or technical team, somebody who has technical experience within the kind of remit of cybersecurity incidents. We have the triage phase. Identify risks, potential business impacts, and make a declaration of the incident implementation containment measures. So at this stage, we need to make a declaration as to whether it's a full-blown incident, for example. We perhaps give it a classification. We then go into action phase. So the containment phase must be done before the incident overwhelms resources or the impact increases. And again, that's going to depend specifically on what type of incident it is. If it's ransomware, it's going to be different to if it's a web compromise or a phishing email or even a breach of the physical perimeter. Eradication, eliminating certain components of the incident, such as deleting the malware or disabling broadband, whatever it may be. Again, thinking about the knock-on effects that could have and how are we going to be suitably assured that we have eradicated it. Gathering and preserving evidence, as I've mentioned before, gathered at every point during that investigation, because we're going to need that information whenever we do any reporting. So when we report to the Information Commissioner, for example, we're going to want to have as much information available as to what happened, who was affected, what kinds of data did they have access to if it was that kind of attack, and what are we doing to make sure that it doesn't happen again. The recovery process, so if it is a system that's been taken down, recovering that system. If it's data that's been compromised or lost, restoring that data. However, being mindful that we restore systems only when we're assured that the attack has been thwarted. It may be a case that the attacker is aware that you have you've caught them. You're making changes, so they may lie dormant. You may not have actually removed them from the system, so you don't want to go restoring systems and data because it may give them access to it. We need to be very certain that the attacker has gone. Also, if an attack has been successful, the attacker is more likely to come back because they know that they've attacked you before. And then the follow-up process, as I mentioned, learning and improving following an incident, follow-up tasks, follow-up questions, areas for improvement, a full post-incident review with kind of a detailed root cause analysis, lessons learned, possible digital forensics, and certainly interaction and agreement and direction from the senior management on that. So typical attack scenario, just very briefly, if we think about a banking user, a detection could be an attachment in a spear phishing email, downloads a piece of malware, let's say it is a piece of ransomware. They would obviously have some disruption to their workflow. Their computer would change, it'd be their computer be unusable. Possibly as well, they may be using network attack storage devices, file shares, all those sorts of things that may cause the malware to spread if we don't have suitable controls in place. That may also impact other users, customers, clients, for example. The user or users realize and report the issue to the IT desk. Help desk gathers the relevant information from the user, asking what they did, what they clicked on, what does the malware look like, screenshots, for example, can you describe it? Do you know the name of the malware? All those sorts of details. Specifically as well, and importantly mentioned before, time stamping all of this information. Going through the investigation process to establish the key information. The triage phase. So further analysis, classify the severity of the incident. So maybe it's our company policy that we treat all ransomware incidents as a tier 1 critical priority. Deployment of the response teams to support and issue an internal incident notification. So perhaps send a communication out that we're having lots of traffic, lots of phishing emails, perhaps we're under attack from a dedicated phishing attack, as well as being mindful of the communication channel that you use. If you're having a phishing attack and you're starting to send out lots of emails, again, people may think that that's phishing, so perhaps have different processes that you've tested and approved for that. Maybe pick up the phone, for example, call the regional business head, whoever they may be. The action, the incident response team to review the damage caused and judge if the incident has been contained. So again, that could be ongoing monitoring of systems. Certainly with ransomware, we see disk utilization, network traffic going up, things like that. Maybe that's gone dormant. Maybe with the controls that we put in place have worked. Maybe we've segregated the network, the affected systems. Perhaps we've patched. We know that there's a fix available and we've gone ahead and deployed the patch. The recovery plan. So once we know that those signatures are available, perhaps for the anti-malware scanner, we ensure that they're all deployed. We do a full system scan of our entire network, our shared folders, and we're suitably assured that the attack has gone, the malware has been removed from the network. And then we follow up with a root cause analysis. So what was the reason for it? Oh, it was an email that came internally, so it wasn't scanned by the email scanner. That user had brought in a USB stick that day that had some malware on it. Whatever it may be, we think about why that actually happened, what caused it, and what steps we could put in to make sure that it doesn't happen again. The reporting process, as I mentioned before, those suspicious events should be reported to IT or service desk to remove through the reporting escalation process. Critical that we have those dates and timestamps, and certainly as any kind of system admin for certainly in the IT networking department, things like NTP servers, making sure that all systems and logs are correlated such that when we do that kind of more in-depth analysis, we can correlate those logs. We can see that an incident here had a knock-on impact here. The physical location, the type, and critically, yes, the sensitivity of that data. Certainly if it's a breach of personally identifiable information, that's going to be very important. What kind of personally identifiable information was it? Current status of the incident, so are we ongoing? The source or the cause, if we know it, the more information we can give during our reporting process, the better. And then a description of the incident, of how it was detected. Was it an end user? Was it something that we monitored on our systems, for example? Was it something we were alerted to? And that concludes today's session.